All right, I'll be right with you, gentlemen. Okay. All right, so welcome. Let's see. It's there are no major announcements. We finished up exam 2. Last week, so Monday, we took some time to do one-on-one sessions to just make sure that as many people were positioned for success as possible. So we're just going to continue with the next section today. So normally, I do the lectures, but since we lost our Monday, then I'm going to rely on my pre-recorded lecture. So the lecture for section 2.1, is the lecture for every section is already available. So you would have to check out the pre-recorded lecture. So what we're going to do today is work through as many homework questions as we can, right? And I think I set this up so that we can actually do these in like a poll format. Okay. So this question asks us to identify the graph, right? So is it A, B, C, or D, right? So we have y equals -1/8 x squared. So if we think in terms of transformations, right? X squared, meaning that we're going to have a U-shaped curve. We multiply the outside of our basic function by 1/8, which is a number between 0 and 1. So that means that we're going to have a vertical compression. We're going to smush it vertically, right? So it should be, short and wide. And then we multiply the outside by a negative, so it should flip vertically. So it should flip top to bottom. So the only one that's short and wide that was flipped top to bottom is C. It can't be B or D because those are turned the wrong way. And then A looks like it was moved up some amount, like by like 2 or something like that. So yeah, C looks like the one that's proper. Let's go with C. Okay, let's try another one. Let me relaunch the poll. Okay. All right, so we can still identify this based on transformations, right? So it's still a parabola, so it should be a U-shaped curve. We have about 3 transformations that we're considering. So the recommendation is that when we're doing multiple transformation in one go, right? Okay, let's see, B. We work our way from the inside to the out. So that +2 tells us to go left 2. We stretch it vertically by a factor of 3, so it should be tall and narrow. Flip it top to bottom, so it can't be A or D. And I think that's it. I think the problem with C is that it went the wrong direction, so I can get down with B as well. All right, let's check it out. Let's go on to the next one. Let's relaunch this. Okay. All right, so another one on transformations. Which one do you think it is? A, B, C, or D? 2 transformations says that -3 tells us to go right 3 and then down 9. There's a vote for B. I'm just up. It's not B, right? Because if we're going down 9, right 3 and down 9. So it should be, yeah, A. Because I think, because B went the wrong direction. Oops, check the answer. Okay, let's see what we got next. Okay, let's try another one. Let me relaunch the poll. Okay. So it says match the function with the corresponding graph, right? So we can still do this. Now, this is actually what's called the standard form of a quadratic. It's the a times x minus h squared plus k. But we can still do this based on transformation. So we have a U-shaped curve. It says to go what? Left 5, down 5, and stretch vertically by a factor of 2. Yeah, right. So I think that it can't be C or D because those are turned the wrong way, and A went the wrong direction. So B sounds good, right? Let's try another one. Relaunch. Ooh, this is giving me ideas. I'll probably do that going forward. Maybe. I just don't want to give myself a whole bunch of extra work. But this is actually really, I like this. Find a quadratic function of this form. Okay, now this one is not multiple choice. Now, here, let's go like this. And we can zoom in some. That's looking good. So find a quadratic function of this form. Oh, let me check one other thing. Close. Find a quadratic function of this form that passes through this point, right? So basically it's saying when x is -3, y should be -36. So when x is -3, -3 squared is 9. So basically I'm plugging in my x and my y. So -36 divided by 9 is -4. So that means that a is -4. So we could say -4x quantity squared. Okay, let's go with that. Let's go to the next one. Now, if I need to write this stuff out, just let me know. I'm just kind of, we're actually finding the quadratic function that has this vertex. Let me write this one out. So I'm gonna start by getting a copy of it. Okay. So let's take that. We're gonna drop it here. I guess it's one. Yeah, let me just go like this. Okay. All right. So find a quadratic function that has this vertex and passes through this point. Okay. So there's a couple of things here. You want to be aware. Let me see. So first, we're going to be using the standard form of a quadratic. The standard form of a quadratic takes on the form y equals a times x minus h squared plus k. That's the standard form of a quadratic. Where the h comma k are the coordinates of our vertex. And there are times when we jump straight to the vertex. It's a thing called the vertex formula. And that's going to be our h equals negative b over 2a. Okay. That's basically the x coordinate of our vertex. And then the k is just going to be f of h. So whatever answer you get for h, you pass it through your function, and that's the k. So that's the vertex for our parabola, right? So we're given that the vertex is 0, 0. And the point on the graph, -3, -27. Okay. And we're going to put this into our standard form of our quadratic. So the vertex is our h and our k. And then this is our x and our y. And again, we're going to pass it through the standard form of a quadratic, which is y equals a times x minus h squared plus k. Okay. Okay, so if we plug in what we're given, we don't have any information on a just yet. We have that x is -3, h is 0, okay, squared. Our k is 0, and our y is -27. So if we simplify this down, 9a equals -27, so then a equals -3. Okay. So then our quadratic is going to take on the form y equals -3 x squared, and I think that's it. Can I paste? Nope. Okay. Okay. So we got -3x squared. Let's hop back to Pearson. So we got negative 3x squared, okay? Find a quadratic function that has this vertex. So notice that when x is 0, y is 0. When x is negative 3 squared is 9. 9 times negative 3 is negative 27. All right, so this quadratic works for both of those points. We're going to go with it. Okay, what's the time? Let me check Zoom. Chat looks good. Okay, you guys look good. Okay. This was the same deal, but the vertex is now 1, 2 passing through 2, 5. This is question 17. Okay. So this is question number 7. This comes from 2.1, question 17. 1, 2. 2, 5. My device is kind of slow. See if this works. So this is this was the given vertex. This was the given point, and it's basically a repeat of the previous question, just we changed the vertex and the given point, right? So we still want to use the standard form of a quadratic. So that's going to be y equals a times x minus h squared plus k, all right? The vertex, this is going to be our h and our k. The point given is going to be our x and our y. So then if we plug in what's given, we're solving for a. X, we said, is 2. H is 1. K is 2. And y is 5. At this point, we have one equation, one unknown we can solve, right? My dog is dreaming and she's making some weird sounds. First, I was like, is she okay? And then I realized she was dreaming. It's so creepy. She's like, yep, like these little chirps. And it's so, I don't know, it's weird. Okay, so we have one equation, one unknown, so we can solve. So then 2 minus 1 is 1, squared is 1. Subtract 2 on both sides. So that's going to be 8 equals 3. Okay. So then the equation of our quadratic, or the formula for our quadratic, is going to be 3 times x minus 1 squared plus 2. That should be it. Let me copy. Paste. And again, everything you see me writing, you'll get a copy of it. I'll make a copy available before we part ways today. Okay, so 3, negative 1, 2. 3, negative 1, 2. Right here. So we got 3 times x minus 1 squared. 3, negative 1, 2, right? So let's check. Type your answer in standard form, okay? So let's check and make sure that this works. So when x is 1, then the corresponding y is 2. When x is 2, 2 minus 1 is 1, squared is 1, times 3 is 3, plus 2 is 5. So this works for both of those points. So we're going to go with it. Okay, let me just check Zoom really quickly. Looking good. Okay, on to the next question. Determine the quadratic function of this form whose graph is given. So this is a repeat. It's just presented a little bit differently, right? So our x is negative 6, 0. Our y is negative 5, 1. 8 and 23. 8 and 23. 8 and 23. Right, this is question number 8. This comes from section 2.1. I think it's 23. I think it was negative 6, 0, negative 5, and 1. I think that's it. Negative 6, 0, negative 5, and 1. Okay. And these were the coordinates. don't even know why I did that. These are the coordinates of our vertex. This is just a point on the graph, okay? Standard form of a quadratic, y equals a times x minus h squared plus k, all right? Vertex, this is our h and our k. This is our x and our y. So let me see, we don't have any information on a, but their x is -5, our h. So if we say minus a -6, double negative is going to become positive. Our k is +0 and our y is 1. So basically I plugged in everything that was given into our standard form of a quadratic, okay? So -5 + 6 is 1, squared is 1, times a is a. So long story short, a equals 1. So then we get y equals, we're going to have this x + 6 squared, and I think that's it. Because the k is 0, all right? So let's copy, okay. So it's just x + 6 squared. Okay. Oh, it's not a 6 right here. Okay. And notice that when x is -6, y is 0. When x is -5, y is 1. That's about the best we can do there. Okay, this is kind of a 25, 3, -3, 4, -2, 9, 25. 2.1, 25, 3, -3, 4, and -2. Okay, I think these are all. This was like a vertex. This is a point on the graph, right? And it's a repeat, like the previous, right? Okay, I think we're fine. Okay. So the standard form of a quadratic, y equals a times x minus h squared plus k, all right? Let's see. This is our h, this is our k, this is our x, this is our y. Okay. So then the a, we don't have any information on a. So x is 4, h is 3, k is -3, our y is -2. So at this point, we have one equation, one unknown we can solve, right? Everything is filled in except for a. If we add 3 to both sides, on the right-hand side, we're going to get 1. And 4 minus 3 is 1 squared is 1. So that's going to be a. All right. So then we get y equals, looks like it's going to be x minus 3 squared minus 3. Okay. Minus 3 minus 3. Parentheses, x minus 3 squared minus 3. I mean, we can check, right, before we submit it. Notice that when x is 2, 2 minus 3 is -1 squared is 1. 1 minus 3 is -2. That checks out. When x is 3, y is -3. That checks out. When x is 4, it's going to be a 1 minus 3 is -2. So this works for all those points. Okay. Let's see. So we're asked to graph. Oh, we're asked to write this one in standard form. Okay, let's I think we need to take some notes on this one. Let's move this about here is good. All right, we want to take a copy and drop it here. So I'm running out of space. Yeah. So let's move this. Okay, let's add a page. Let's add a few more pages. And again, everything you see me writing, I'm going to make a copy available, at the end of class. And not only can you access the notes from your class, because I'm teaching like 4 sections of the same class. So I live stream all my sessions with all the classes, so you can watch their session and use their notes as well. Let's see. So with this one, form, but to do that, we have to use a factoring technique called completing the square. So with college algebra, you are expected to have a command of factoring, but I acknowledge that most students do not have a command of factoring. That's why you all have like a lab portion to try to strengthen some of those things. But this is like one of those techniques you're expected to know. So what we're going to do here, we're going to take some time to do a demo on completing a square, right? So if we're starting with y equals x squared plus 8x, right? The first thing with completing the square is that the leading coefficient needs to be a 1. We got fortunate in this case because it already is a 1, right? So we're going with it. So then the next thing, what we're going to do is we're going to add 0 to this formula or this equation, but in a certain form. So it's not going to change the answer, or it's not going to change the solution, but it'll put it in a form that we can use to do what we need to do, right? Do we need completing the square here? Anyway, so then completing the square, we're going to say plus b over 2 squared and minus b over 2 squared, okay? Or b in this case being 8, so we're going to say plus 8 over 2 squared and minus 8 over 2 squared, right? So then if we keep going, again, this is completing the square. So 8 divided by 2 is 4, squared is 16. So we're really saying plus or minus 16. We're adding 0 in the form of plus or minus 16. So then if we group the first 3 terms together, now we can use factor by grouping. This factors into, I think it's x plus 4 squared minus 16. Because 4 times 4 is positive 16, 4 plus 4 is 8, right? So it factors into this form. But we were able to get to this by using completing the square. Okay, that just, I don't know. You just have to be aware of it, and it takes a little bit of practice. Plus 4 and negative 16. Now we got to try to get back. It's a different one. This one. Okay, we got plus 4. Okay, let me zoom out some. Come on. All right, I think I had to go like, there it is. See, I knew it was gonna do that as soon as I Okay, I think we're good. Okay. +4 and I think -16. Here, y equals x plus 4 quantity squared. I'm going to say -16. I'm just going to go with it. I'm trying to look for something so I can check it. Yeah, I think I'm going to just go with it. Okay. So then in this form, this is saying basically take a parabola, go left 4 and down 16. So we're going to go 4 units to the left and 16 units. 16 units down. Okay, let's check that one. Click the graph. So we're doing a parabola, and I'm just gonna, I chose the parabola tool, then I'm just clicking on the origin. We don't want to reflect, so that wasn't proper. We said left 4, so I'm gonna just slide this to the left by 4 and then down by 16. Okay, I'm gonna hit save. It's just a parabola. We went left 4, down 16. Let's check. Okay, let me check on you guys in Zoom. Wait, the vertex, right? So in this form, this is, because remember, this is x minus h squared plus k. So when we have that x plus 4 on the inside, we need to rewrite it as minus a -4. So then the coordinates of the vertex are -4, -16. Parentheses, -4, -16. Okay. Check the answer. Cool. So the axis of symmetry is the x coordinate of the vertex, which is going to be x equals -4. Okay. So with the axis of symmetry, when you know the vertex is an axis of symmetry of the parabola, whenever you get one point on one side of the axis, you automatically get a point on another. So with the vertex and the axis of symmetry, it makes graphing parabolas easy, because you get all the points are 2 for 1, except for the vertex. Let's see. The x-intercept, right? So if we want to find the x-intercept, we set y to 0 and solve. So it should be what, 0 and -8. I just did it in the original. I didn't write it out, but if you set y to 0 and solve, right, you can factor out, you'll have x times x plus 8. And then, set each one to 0, you'll get 0 and -8. So we got -8, 0. And again, if I need to write this stuff out, I just have to request it. So again, for the x-intercept, we set y to 0. So then for the y-intercept, we set x 0, and the output is 0. We'll get 0. Okay. Checking you guys in Zoom. Okay. I know we got a straggler. All right. Yeah, you could just go. Like, I mean, if you leave, I'm not gonna know. Like, as long as you're just like present and just, getting what you need out of it, it's okay. Okay, so the thing with my class is, like, basically I'm running this as if you guys are adults, right? I know you're right out of high school, but at some point you have to like start being accountable for yourself. You have to start making decisions for yourself, right? So I'm kind of like hands off with my class, but I do that just to kind of de-stress for everybody, not only for you guys, but for myself, right? Because if I was like so nitpicky about trying to control every little facet of your life, it'll drive me mad, right? So I was just like, no, I'm not interested in that. I'm interested in talking about math, trying to help you on your way and treating you guys like adults, right? So what that means is you decide for your life. If you make a plan for yourself, you make a decision and you take action. So I don't do a lot of micromanaging, but I'm just running it the way I would like to be running. Like if I was in a class, that's how, I would just like it for my professor to be available, things of that nature. Kind of hands off, but I'm doing whatever it is I need to do to reach my goal. Let me see. Graph this function by writing it in standard form and then using the transformation to find the vertex. Okay, so write this function in standard form. Let's see. Let's go like this. And it's not foolproof, that strategy, but that's just what works for me personally, to keep my stress levels down. So I'm not like angry about everything, because I was like, hey, my life is too short to be angry about stuff. I don't think anything really here is really worth being upset about, because with everything that happens, there's always another way to get things done. There's always somebody else to talk to, some other route. There's always something else, right? So you just do the best you can with whatever you have, and if it's not working, you do something different, right? Just make it. All right. So here, all right. I don't think I made it this far with anybody else today. So this is like my first time doing this one. We're asked to graph this function. First, we're asked to write it in standard form, right? So this is an example of one where the leading coefficient is not 1. This is looking pretty nasty. I'm trying to think if there's a simpler way. We could use a quadratic formula. I don't think I want to do that. All right. And then transform it. Okay. I'm not liking how that's looking. Okay, I think I got it. So we're gonna use completing the square like we did before. These numbers are a little bit more challenging, so we're just gonna give it a go. So we're starting with y equals negative 5x squared plus 50x minus 44, right? So completing the square, we're still adding 0, but we got to do the whole negative b over 2a thing. Okay, so again, the first thing we'll complete in the square is that leading coefficient needs to be a 1. So let me think. Because if I do it there, b over 2a. So I'm pausing because I'm trying to think of how to keep these things as simple as possible, because there's a couple of different ways that we can go about it. There's something I want to try, but it might mess up. There's another way where I'm less likely to mess up, but it's going to be way harder. I'm just trying to think. Give me a moment. I know there's a way to do it. Let me see if I do that. And then if I do it there, okay, I'm going to try the way that I think might be more simple, but it might not work. If it doesn't work, we'll adjust and fix it. So again, the first goal is to get this leading coefficient to be a 1. So what I'm going to do, I'm going to factor out a 5 from just the first 2 terms. That's why I was pausing, because I was like, I've seen it where they only factor it out of these 2 and they got it to work. But my intuition is saying you got to factor 5 from all 3. And so if I try to factor 5 from this guy, that's the one that's throwing a monkey wrench, right? So I'm going to try the technique where it looks cleaner, but there's a greater chance that I'll make a mistake. But let's give it a go. So if I factor out 5 from the first 2 terms, we're going to get something like this. Negative 5 times, we got this x squared. That's not going to be a plus anymore. What is that? 10, negative 10, so minus 10x. Right, so we just factored out a 5 from those 2 guys, and this minus 44 persists on the side. Okay, now I left some space, so we're still going to add. So this is completing the square. We're still going to add 0, but in a certain form, so that we can factor this guy inside the parentheses. So we're still going to use our negative b. No, we're going to use b over 2a squared, right? So we're going to say plus b over 2a quantity squared and minus b over 2a squared. Okay, let me think about this. I think this is going to work. Let's keep going. But if the a is always 0, Okay, let's keep going and see what happens. So if our b is -10, that's going to be -10/2 squared plus and minus -10/2 squared, right? So we're adding 0 in this form of -10/2 squared, right? Let's keep going. So then this gives us y equals, we got this -5, we got this x squared minus 10x. So then -10 divided by 2 is -5 squared. So we're basically doing plus 25 and minus 25. Okay, I think we're okay. And then everything else is staying the same, right? What space I have. Okay, I think I'm good on space. So then, all right, so what I'm doing, I'm basically factored by grouping, right? I want to consider those 3 terms to the left. I want to kind of group those together. And really, and I'm also kind of like distributing this -5 into the 2 different parts, okay? We gotta be aware that we're distributing that -5, okay? So then if we do this, so if we focus on those 3 terms to the left of the green bar, they factor, so this -5 just comes down. It's gonna be x minus 5 squared. And then -5 times -25 is a positive 125 minus 44, right? Because basically I was grouping it, like I was considering this as one term or one thing, and then this is another. So that first red circle, you can see it here. The second red circle, you can see it here. And then the 44 just came down. So this is here, this is here. Okay. So combine like terms, I think we're one step away. So again, this is another reason I was pausing, is because completing the square typically gives students a hard time, right? And so I was trying to think of the best way to present it, because another way we could have done it, another way I've seen it done, we factor out 5 from this, and this. So then we would have been dealing with fractions. And I was trying to think, okay, can I show it while avoiding the fractions? That's why I was pausing. And it seems like we were able to do it. So let's try to wrap this one up, right? So all we just want to combine that 25 and that -44. So then we get this comes down, everything else comes down. Let me see. So minus 20 will put us at 105, and then 95, and then 85. So then 81. All right, so then plus 81. Okay. So completing the square, our claim is that this is the standard form of that original part. Okay. Okay, this is it. So let's see. Graph this function. Okay. So we got the following. Now I think that, so -5 times x minus 5 squared. Let me see. Minus squared. Nope. Squared. I think it was plus 81. Okay, let me see. I'm trying to see if I can check it. Only way I can think to check it, I would have to expand it out. That x minus 5 squared, you have to FOIL, distribute the -5, combine like terms. I think I'm just going to go with it, right? Just for the sake of time. Awesome sauce, okay? So we were successfully able to complete the square there. So then in this form, this is saying that now we can use transformations to graph this quadratic. We basically have a U-shaped curve. We go right 5, up 81, and it's upside down, right? So let's do it in the proper order. It goes right 5, stretched vertically by a factor of 5, so it's tall and narrow. We flip it upside down, and then we go up 81. So it's an upside down skinny parabola in where the vertex is in quadrant 1. An upside down skinny parabola so it has to be either A or B. And we said quadrant 1, so it has to be A. Okay, let's go with A. The vertex is at 5,81, right? Because in this form, this is A times X minus H squared plus K. So the H in this case is 5 and the K is 81. So 5,81, parentheses, 5,81, okay? And the axis of symmetry is the X coordinate of the vertex, so that's gonna be X equals 5, okay? Any x-intercepts, so we set y to 0 and solve. Let's see, if we set y to 0, okay, let's get it nasty, right? Because you subtract the 81, divide by -5. Let's see, what does it say? Exact radicals is needed. Okay. So right here. Yeah, I was trying to do it on my head, but let me just write it out. I think we have a copy of that already. So if we want to find the x-intercept, we set y equal to 0 and solve. All right. Let's kind of work here. And let me get a copy of this guy. So we have y equals -5 x minus 5 squared plus 81. So if we set y equal to 0, so then I'm going to move y to the right-hand side. -5 x minus 5, thank you, I know, squared plus 81 equals 0. You can subtract 81 on both sides. You'll get -5 x minus 5 squared equals -81. Divide both sides by -5. X minus 5 squared, 81 over 5, okay? Now you take the square root. I think 81 is a perfect square, 9 times 9. So when you take the square root on both sides, you get x minus 5 equals plus or minus 9 over the square root of 5. I'm gonna leave it just like that for simplicity's sake, okay? As you take the square root on the right, square root of 81 is 9, square root of 5, just left it as is. And then you add 5 to both sides, 5 plus or minus 9 over the square root of 5, okay? So those are the coordinates of the x-intercepts, right? 5 plus or minus 9 over root 5. So then we're gonna put that here, if we can get this to behave properly. I think it was 5, right? 5 minus 9 divided by the square root of 5. I'm going over to the side and hit comma, and then 5 plus 9 divided by the square root of 5. So I think that's it, all right? For the x-intercept, because I wanted exact answers using radicals. And then the y-intercept, basically, you set x to 0. Y-intercept oftentimes is a lot easier than the x-intercept. If we set x to 0, that first term is gone, the second term is gone. The only thing that's left is -44. Okay, all right. That was an adventure, right? Okay, guys, you have any questions?
I have a question, but like it's something else.
Right. So let me go ahead and make a copy of all the things. Yeah. Is it streaming on YouTube, or it doesn't need to be private?
Yeah, like private. Okay.
Okay. Did anybody else have any other questions before we part ways? Okay, let me go ahead and make a copy.
Sir.
Yes, go ahead.
Oh, nothing, sir. Sorry.
Okay. Yeah, let me just make a copy of this available. Okay, we want it there. Send a box. Ooh. All right. So once this bar finishes loading, you'll have a copy of what we discussed. And aside from the question that we're about to address, if there aren't any other burning questions, we're going to end the session here. Just kind of keep working forward. We only have 3 sections in chapter 2. Then we're going to take exam 3 is just going to be over those first 3 sections of chapter 2. After exam 3, it's only 2 sections, and then that's it. We're done. All right. So on that note, we're going to end the session here. I'll be right with the other student in just a moment. And from one beautiful mind to another, enjoy the rest of your day. Take care, guys. Peace. Let me just stop the stream.